The numbers are staggering: $10 billion, 25 years of design and development. NASA sent $10 billion worth of delicate hardware screaming into the skies above French Guiana when it launched the James Webb Space Telescope. NASA scientists and officials have for decades anticipated this space-based observatory, seen as successor to the famous Hubble, and the discoveries it could bring as it peers even deeper into the universe's multi-billion-year-old story. But they are equally nervous about the precision required for its success. Despite not even being at its eventual million-mile orbital distance from Earth, the telescope has already seen its fair share of challenges: delays caused by hardware hiccups, like loose screws, work pauses due to its sheer complexity, the coronavirus pandemic, and general cost overruns leading to multiple federal investigations. JWST, or Webb for short, is the first big telescope to rocket past Earth's atmosphere since the Hubble Space Telescope, which launched in 1990. Webb, a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, is 6 times larger and 100 times more powerful than its predecessor. Astronomers expect to fill a mysterious gap in the historical record of our universe, the first 400 million years after the Big Bang, and to identify distant worlds that could host alien life. An Ariane 5 rocket, with Webb tucked inside its fairing, roared to life and heaved itself off a launch pad at Europe's spaceport in French Guiana at 7:20 a.m. ET on Saturday, 24th December 2021. Roughly 3 minutes later, 75 miles above the Earth, the rocket's nose shed its outer shell, exposing Webb. The body of the Ariane 5 rocket fell away, leaving its upper stage to fire its engines and give Webb one final boost away from Earth before it too separated and fell away. A decade behind schedule and over budget, Webb has finally careened into the blackness of space. Over the next 6 months, it has to unfold itself, align its mirrors, calibrate its instruments, cool a frigid -380 degrees Fahrenheit, and travel 1 million miles from Earth. Then it can begin to study the universe. Bill Oakes, NASA's project manager for Webb, said in a November press briefing that he won't breathe a sigh of relief until they declare we're operational, 180 days after launch. Webb will unfold itself in space, with 344 opportunities for failure. After liftoff, it will take a month for Webb to reach its destination, in orbit around the Sun, trailing Earth by 1 million miles, which is about 4 times the distance between the Moon and Earth. Along the way, the telescope must unfold itself, a risky proposition, launch checkouts and unfurling maneuvers. The 3 agencies responsible for the telescope, NASA, European Space Agency, and Canadian Space Agency, call it 29 days on the edge. According to the Space Foundation, a nonprofit that advocates for space activities and conducts studies, there are 22 active space telescopes operated by more than a dozen countries. Webb, however, will need to differentiate itself from those by executing the most complex set of deployment maneuvers ever attempted. Webb has 2 major components: a hexagonal mirror made of 18 gold-coated segments, and a sun shield the size of a tennis court, which deflects sunlight to keep the telescope cool. The roughly $10 billion telescope has to be folded and stowed to exact specifications in Ariane 5's payload fairing, survive the vibrations of the launch, then spend 29 days unfurling into a sunflower-like telescope with a massive 72-foot sun shield below. NASA folded them up like a drop-leaf table. Unfolding Webb is hands down the most complicated spacecraft activity we've ever done. Mike Menzel, NASA's lead mission systems engineer for Webb, said in a video on the subject. Webb's design includes 344 unique mechanisms with no backup. NASA calls these single-point failures, since each must work perfectly for the telescope to function. About 80% of those points are part of the 2-week unfolding process, Menzel said. The Northrop Grumman-built telescope's activities will need to follow a strict schedule of powering up, deploying the many components, and firing thrusters to reach its final destination, about 1 million miles from Earth. A spacecraft systems engineer at Northrop Grumman said during a pre-launch conference that NASA has performed multiple deployment testing over several years on both small and full-size models. Not only deployment, but the stowing process. This gives us the confidence that Webb is going to deploy successfully in orbit. If something goes wrong during any of those processes, Webb will be on its own for now. As it stands, there are no companies or countries capable of launching a servicing mission to fix Webb in its orbit well beyond the Moon. Missions like those launched in the 1990s to repair Hubble won't be possible for at least several years, assuming officials agree to fix it in the first place. However, if it unfolds according to the plan, Webb will then spend about 4 months aligning and focusing its mirrors. Then the observatory will calibrate its science instruments, 4 cameras, and spectrographs designed to observe the universe in different wavelengths of infrared light. Webb's first year in space could change our understanding of the universe. For telescopes, peering into the distance is always looking back in time. That's because it takes time for light to travel. The farther away an object is, the older its light is by the time it reaches Earth. Thanks to Hubble, astronomers have seen the light of ancient galaxies from 400 million years after the Big Bang. Some of those galaxies were much larger than scientists expected, meaning they grew rapidly in those first 400 million years. We have this 13.8 billion year story, the universe, and we're missing sort of a few key paragraphs in the very first chapter of the story, Amber Strawn, a scientist at NASA's Webb team, said in a November press briefing. JWST was designed to help us find those first galaxies. During its first year, Webb is scheduled to hunt for those primordial galaxies, as well as conduct nearly 400 investigations from thousands of scientists all over the world. Those projects include imaging every planet, moon, and asteroid in our solar system, starting out with Mars and moving outwards, analyzing distant planets' atmospheres for gases that could signal alien life, and searching for signs of platinum and gold that's forged when massive dead stars collide. Webb's infrared cameras will also allow it to peer through clouds of dust that obscure the universe's stellar nurseries, the dense regions where gases collapse into stars. NASA has launched a controversial name into space. Webb's name has stirred controversy. More than 1,000 people, including scientists who applied for observing time with Webb, signed a petition to rename the telescope earlier last year. The petition argues that the telescope's namesake, James Webb, NASA's second administrator, helped enforce government policies discriminating against LGBTQ employees in the 50s and 60s. Webb's promises. Webb's 21-foot gold-coated mirror is the star of the show, but the Lockheed Martin-built near-infrared camera, or NIR-CAM, is what will enable scientists to peer through cosmic debris and dust clouds using the infrared spectrum. Overall, the telescope is touted as being roughly 100 times more powerful than Hubble. This telescope is so powerful that if you were a bumblebee hovering 240,000 miles away, which is the distance from Earth to the Moon, we would be able to see you, said John Mather, an astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. But what specifically do scientists want with such a powerful telescope, unencumbered by Earth's volatile atmosphere and light pollution? To look at everything there is to see. John Mather says that they want to know how we got here from the Big Bang. So we'll look. We have ideas, we have predictions, but we don't honestly know, he added. From the Big Bang to the formation of galaxies, to our solar system and life itself. Mather said, the universe's 13.8 billion year-long story is nowhere near being told. Webb's infrared imager means scientists can peer not only farther than ever before, but also deep into clouds of gas and dust that eventually give birth to stars. Dark areas of dust are obscuring our views of those earliest times, when the stars were growing, but we can see them in the infrared. Infrared will go around the dust grains instead of bouncing off, Mather said. It's one of our top goals, to see how stars grow with their young planets. All in all, some 10,000 people have worked to make Webb possible. Some started early on, and have since moved on to other careers or fields. Others have stayed with the program throughout. Project scientist Klaus Pontoppidan says that they are about to go on this amazing journey of discovery, and we really mean discovery because Webb has this broad power to reveal the unexpected. He noted that Hubble's discoveries created entirely new fields of study, and thinks that Webb will be no different. Webb will probably also reveal new questions for future generations of scientists to answer, some of whom may not even be born yet. Now that you watched the video, let us know what you think about the opportunities the Webb telescope could offer. Let us know in the comment section below.